You can start, Akash.
Yeah. So architecting authentication, understanding sessions, JWT, and OAuth. Before getting into the topic, first of all, we shall discuss what is authentication. So might be you have an idea of authentication and authorization, but you might not have any clarity like what is it, what is the difference between them. So coming to authentication, before you are willing to join some website or log into some website, the website has to first allow you to log in, right? So in that case, in order to judge who are you and justify whether you can join or not, and giving you permission to join, so it first identifies who you are, and after knowing that you are the deserving person, and then you'll be able to join. So that is what about authentication. And authorization is after you join the website or log in the website, then it is all about permissions that you are given, that you can do so and all. So that is authorization. What you can do is authorization, and the and the point that you can log into the session and you can find whatever you want on the website, that is authentication. So getting into the stream, we'll deal with stateless and stateful authentication and authorization process. So here we'll go ahead. Please move to the next slide, Pawan. Yeah, the foundational problem, as I said earlier, what is the difference between authentication and authorization? Authentication, it verifies exactly who you are, whether you are the person to join, whether you have joined earlier, or if you have joined earlier, then it judges or verifies whether you are the person who have joined earlier or not. And authorization, it verifies exactly what you can do. I mean, the permission is granted to you that you can do so and so task on the website, right? Then comes the HTTP problem. Like, what is the problem you might face with HTTP? Before going through that, let's understand what is actually HTTP. HTTP gives a meaning of hypertext transfer protocol. So that's a protocol which you might understand going ahead in the website and web development, right? So that is again a stateless protocol where the main problem what you'll face with HTTP is that after you join the or after you log in the website, then it might be difficult. It might be difficult to identify each and every request, and it treats every single request to be the same rather than treating it to be unique, right? HTTP treats every single request as a brand new conversation with a stranger, even though the person or the request which it receives actually might be known or unknown. It treats it to be the same. So without an identified persistence mechanism, users should log into on each and every single click, right? So need not log in. Need not go through any procedure. The login turns very easy and very simplified. While uh, yeah, please move ahead on stateful authentication. Now assume you're visiting a restaurant and you'll be given a unique pass. A pass that so that you can move in and out of the restaurant each and every time. And after you are given a pass, it's up to you whether you move out at your frequent times or not. So in the same way, the stateful authentication is similar to the way the authentication, the unique pass is given, and you can see the metaphor. A visitor receives a unique pass from a guard with a master logbook. So after you are receiving a unique pass, you can use it however you want, and that is noted into the logbook. And then if it is erased from the logbook, then it is also understood that you are no more a customer in that restaurant. In that sense, getting into technical words and technical world, how it is similar to the technical world is that the server where where the backend of internet is running, that is the place where the unique pass is issued, right? Server verifies user credentials. Suppose you have logged in the website telling your username and password. So after you are logged in, then server has to securely write the session to a database. That means your credentials would be returned to the session into a database. That means session is a place where your credentials are stored actually. So that session will be written into a database. And then the concept of sticky note is that server returns a set cookie header with session ID. So the cookie is also returned, and the cookie is also related having a session ID. So whenever you log in or log out within a website, each and every moment you log into the website, you are being verified with the session ID. Like having a session ID stored, the moment you log into the website, it verifies whether you have logged in earlier, or it sees whether if you are not logged in earlier, then it creates a new session ID immediately. And the fourth point, instant logout, erasing the logbook entry instantly invalidates the sticky note. That means after entire data of you is erased, then there is no meaning that you are an existing user, right? So that is the main concept of stateful authentication. It is that you are given a unique pass and you're allowed to move in and out, and that pass is a proof that you have already registered. That means that pass is equivalent to a session ID. So having a session ID, you can always move out and move in without any second point. Move ahead on system design and scaling sessions. Now, why do we have to look at scaling sessions? Suppose you have developed a website and also deployed it. You will have to look at the number of users entering the website, right? Suppose initially there are just 10 users joining the or logging into the website, and that might not be a heavy traffic to you, and you could easily handle the website without going to premium services. But what if, imagine the website is actually receiving a traffic of 100 or 100 plus, and it's very difficult to handle that website, and you'll have to also look at the server and regarding the other technical stuff. So there comes the point of scalability, whether the website is able to handle the number of users or not. So in order to talk about scaling sessions, that means um, is the like, are the sessions stored in the right place or not, whether it is scalable or not. In order to check at those places, the main points coming up are in memory, that is RAM, and database, Redis cluster, and then on a whole, it is a trade-off, differentiating the points, right? RAM, suppose you're giving some credentials in order to log into a website, and then after you're logged in, your details are stored under a session or into a session. Session is a place where the credentials are stored, and that session is given an ID called as session ID. So when the session ID is stored into the RAM, it is very easy in order to validate whether the user is existing or not. So it is very fast. And suppose your the website is crashed, or else the website is has stopped execution and you're restarting it again, then at that moment all your credentials are lost. You will have to freshly log into the website again and again. So there comes the point of the credentials being lost or your data being lost, and you'll have to freshly start again. So it is very difficult, or it cannot scale horizontally at all. Then coming to the database, it is durable. Durable in the sense you can go ahead with the database, but it is bit slow. Bit slow in the sense, again, suppose you have logged in and your credentials are entered in the session, and you want to the website wants to validate whether you are an existing user or they are the new user coming up, right? In that process, it has to go to the database, has to give some queries and validate whether you are user you are an existing user or a new user coming up. So in that sense, it is very slow in order to validate as well. So you can see here, it is too slow for high frequency session reads. That means if the frequency is increasing and the frequency of sessions being stored is increasing, then in order to validate, it is very difficult in the case of database. Then coming to Redis cluster. What is the difference between a RAM that is in memory and database and Redis cluster. Redis cluster is a shared session storage. That means we are having multiple sessions and they are organized in a shared manner, and that is all a storage where the sessions are stored in a shared manner. So each and every time you are logging in or logging out, your sessions will be validated very easily. That means very fast, and it is always persistent. And as I told, it is shared across all servers. So Redis cluster is way more easier, way more convenient. But the main point of disturbance is that it also looks about additional infrastructure and all. So there it might not be a heavy difficulty, but definitely it might become difficult, right? And then coming up to trade-off is in overall sense that it's all scaling, but introduces extra infrastructure and a single point of failure, right? Please go ahead, Pawan. Stateless authentication. Now, till now, we were talking about stateful authentication. What were we talking about? Suppose, uh, suppose we are logging into and we are showing a unique pass, what we are given actually, and using that unique pass, we can move in and out. So that is a realistic sense of stateful authentication. Now coming to stateless authentication. You can look at the metaphor given there and also the picture given below. A patron receives a self-contained glowing holographic stamp that a bouncer can verify without a list. Now nowadays you might notice that when you are visiting to some public places, then in order to log in or in order to enter into the place, you need not always show your ID. Rather, you are given a stamp on your wrist or somewhere, and you can show that, and that bouncer or someone verifies that, and also accepts that you're an existing user or existing customer coming in, and he might literally easily allow you inside. So that is the realistic sense of stateless authentication. Now coming to technical world, what happens? The first point, stateless. The system writes absolutely nothing. In the sense, it writes nothing actually. And coming to holographic stamp, server issues a self-contained JSON web token. Now what do you mean by JSON web token? JSON web token in the sense, it is an information about the user, about his details in a JSON format, and releasing a token that will be clarifying that someone has entered, and that JSON web token will be including all the details of the user who has entered, right? Then comes zero network calls. The server mathematically verifies the token's cryptographic signature without querying a database. It need not log in or need not query with the database, and it verifies with the token's cryptographic signature. Having a signature, it actually verifies with the signature, right? And then the last catch, the last point, you cannot cancel a stamp. It remains valid until its mathematical expiration. Suppose a JSON web token is released, right? Then even if you want to expire, I mean, even if you want to stop the validation, doesn't stop actually. It works in a sense until it expires. It keeps working. So what you have to do in order to solve the issue, you will have to set it for a shorter duration, or else you will have to keep freshing the JSON web tokens so that easy validation could be done. Please move ahead on. JWT, anatomy, and algorithms. Now, this slide shows you what are the components. Is kind of a schema about details of user entering, right?
Hello,
So
is my
again,
screen visible
payload
now?
is a
Hello,
decoded JSON.
hello. Actually, I had a power cut. Is my screen visible now? Hello. డాడీ వైఫై ఆన్ చేసిందా? Hello. Sorry, I actually had a power cut. Is my screen visible?
You haven't shared your screen for one.
Is it visible?
Yeah, it's visible now. The next slide. Yeah, JWT provisional traps. While using JWT, you might notice some problems or some issues coming up. So some of them are deletion of logout. We'll read it out. Deleting the token on the client doesn't invalidate it on the server. You must implement block list or rely on short expirations. As I told you earlier, as I've told earlier, the token, whatever is implemented, that works until it expires completely. We cannot exit or we cannot stop the process in between. For that case, the solution what we have what has come up is that you will have to set a duration for a shorter time, and also you will have to keep refreshing the tokens so that existing tokens do not occupy the time. And second point or second trap comes up is the storage dilemma. Local storage is completely vulnerable to XSS attacks. HTTP only cookies block XSS, but open your architecture up to CSRF. So yeah, and next comes mobile network bloat. Appending a 2 KB plus JWT to every single API request severely degrades performance on poor cellular connections. In the sense, uh, with each and every API, if there comes up each and every JWT, unique JWT, then each JWT might occupy some time. In that sense, it leads to high computation and might degrade the performance. So again, that is another trap coming up in the JWT, related to JWT. And next comes secret rotation collapse. Changing your JWT secret instantly and irreversibly invalidates every single active user session globally. Like upon changing the secret key again and again, it might invalidate every session, every user session throughout the website. Please go ahead, Pawan. Delegated authentication, OAuth 2.0. While comparing with the stateless and stateful authentication, what is the new concept coming up, OAuth 2.0? You might have a doubt. So in that case, while using JWT token um, on the on our own or on the user end from the user side, or even stateless or stateful authentication. Here, the main difference is that OAuth 2.0 is something offered by a third-party service, right? Suppose you're logging into the website using Google authentication, then the third-party service need not notice what are your credentials. Rather, it gives you an authorization that you can work in the website rather than checking your credentials, right? That is about OAuth 2.0 and delegated authentication. You might find here the OAuth way valid key only starts the engine, cannot open the trunk or glove box. OAuth solves granting access without handing over passwords. That means without actually showcasing the passwords, it just grants the access in order to go through the website. That means granting authorization. The third-party client never sees your real credentials. It never accesses your credentials. Access is strictly limited via granular scope the permissions. Only after the permissions are allowed or given. Right? Please move ahead, Pawan.
Since like one person has joined, let me admit.
Yeah. OAuth 2.0, the authorization code flow. Here we'll be understanding how does the flow of the OAuth 2.0 happen. Right? First is the resource owner. The first point, user authenticates and grants permission. So as I told you earlier, first of all, user has to enter into the website, right? So in that sense, authentication has to be done and permission has to be given. So user authenticates and grants permission. The second point, you can see there, auth server issues a temporary authorization code. Like without verifying the credentials, automatically it gives an authorization so that user can do whatever he wants in the website. So it issues a temporary authorization code. And the next point, client privately trades the code for an access token, right? Trading in a sense, it might be an exchange or it might be a sell and buy process, right? So client privately trades the code for an access token. In a sense, the client privately trades his uh, code of point with an access token. I mean, is an exchange process. You might understand, right? Next comes client presents access token to access data, right? After an access token is given from the client side, then he can access the data entirely on his own for any duration, right? And the resource server, uh, then the server allows him to access the data, right? So tokens are short-lived. Refresh tokens are stored securely to obtain new access quickly. Please move ahead, Pon. So these are the many types of methods through which we can set up authentication. The first one is in an web application with backend, you can use authorization code. I mean, using the method of authorization code. And if it is in a mobile or native app, you can go through auth code plus PKCE, where PKCE is proof key for code exchange. Proof key for code exchange. That means here, as we learned, we are actually in trade with access token with the server, right? So here PKCE acts in the same way, like it acts as a proof for key exchange, right? Then you can also see that mobile apps cannot hide a client secret from reverse engineering. PKC uses a dynamic cryptographic challenge instead, right? And then coming to server, use client credentials. No human user know at all. And then coming to a single page app or legacy, avoid implicit and password. Depreciated and highly insecure tokens leak in URLs, right? Please move ahead one. I guess you have understood the ways of setting up authentication. Then coming to real world architecture, the hybrid pipeline, like how does it go? How is the process going ahead, right? When you are logging with Google Authentication, then what authorization server, the server actually lets you in or moves you ahead with authentication, and it is also important to consider that it never shows your credentials. Rather, you are given a permission in order to access the website. That in the sense you are given an authorization, not authentication, right? Then you might go through company API gateways and where microservices are utilized, and HTTP only session cookies are released, and based on the cookie, you will be allowed to enter. Please move ahead on. So you might understand how is the security threat landscape, how all the threats happen during the authentication process. The first one, or you might notice, reply and MITM, browser storage, and CSRF and all. These are some kind of threats or ways of explaining how threats may happen and all. Please move ahead, Pawan. Right. Architectural truths and misconceptions. You might notice myths. In case of a cookie, it says I can just store the raw user ID in a cookie, right? So that is totally a myth. That in a sense that is totally false. It is not just that cookie just stores a user ID. Rather, it is different compared to what is showed here actually. And you might also read of all the myths and realities given here. Please take some time and go through it after the PDF or PPT is shared with you. Please go ahead, Con. Right. Here, the differentiation between sessions JWT and OAuth 2.0 is given. You might also observe that the sessions come under stateful authentication, and JWT comes under stateless authentication, and OAuth 2.0 comes under delegated authentication. So I would like to remind again that the delegated authentication is in a sense that a third-party service authorizes you so that you can use the website however you want, rather not sharing your credentials to the authentication process, so that your credentials are actually visible to them, right? And in the stateful authentication, the storage is very flexible on the server side, and that is utilizing RAM or Redis. And coming to JWT, it is very flexible at a client storage side. And coming to OAuth, it actually maintains a node server, so where it is very flexible again. Similar ways, you can also look at revocation, scalability, payload size, and ideal use case, right? Yeah, Pawan, please move ahead. Sessions. This is a final glimpse of what we have gone through. Session is the server remembers writing your sticky note, and JWT, you carry a self-contained cryptographically signed badge. You can relate it to the technical world. This is somewhat realistic and technical stuff actually. Or a trusted notary grants someone a strictly scoped valid key to your car, right? HTTP forgets you after every click.